Namaste learner, I am going to teach you a topic of electric field. Actually, there are three topics I am going to discuss. The first topic is electric field due to charged rod and whose length is infinite. And for this purpose, I consider a charged rod of infinite length, whose linear charge density is represented by lambda, and dq is the amount of charge at the section dx. What is dx or why dx? As you know, we use Coulombic force for the point charge, and here is source charge is as a extended charge. Okay, and for applying Coulomb's law, just consider a small section dx, and this dx is, first of all, consider a source charge and apply the Coulombic force, or by the putting a test charge on point P, unit positive test charge at point P, and due to this plus 1 charge and dq charge at this point, there is a dq charge, and due to this dq charge and plus 1 charge, repulsion causes, and the electric field is dE. dE is the electric field due to a small element at point P, and dq is the small amount of charge at a small section dx, lambda dx, and lambda is represented as the linear charge density. And for this consider infinite charge rod, we have to find electric field at point P. As our requirement, first we consider a small charge element dx, and due to this dx, the electric field due to this is equal to, as you know, k dq upon, one thing is very important, the distance, this is also distance, this is also distance, this is also, which distance is considered, then the distance between two charges, one charge is here and other charge is here. That's why we consider this distance, and this distance is a square, means k dq, dq means lambda dx by x square plus a square whole root whole square, and this becomes k lambda dx upon x square plus a square. This is the made this for your convenience to understand. Suppose this is a rod, charge rod. This is a charge rod, and this is a distance from this, and this is the section of the charge. This is section of the charge rod dx, and at dx dq a small amount of charge is kept, and we want to find the electric field at this point. For this, put here a unit positive charge, and from is dq, and dq is plus 1, both are equal to each other, then electric field like this. Okay, this is the electric field, such like this is the electric field. Similarly, this is the electric field dE. Then the vertical component and horizontal component becomes, this is the vertical component or this is the horizontal component. Vertical component is dE sin theta, and horizontal component is dE cos theta. This one is dE cos theta and dE sin theta. And the another section at the same distance means angle is theta, then also angle is theta, then just you this length and this length here, dx. Another dx is considered here, another dx. Another dx is considered here, and plus one charge. Due to this charge, the electric field is along this direction, and the vertical component is dE sin theta, and horizontal component is again dE cos theta. Vertical component is cancelled out because both are equal in magnitude and opposite in direction, and horizontal component is added, and this is the net electric field due to this charge rod. Means vertical component of dE means dE sin theta cancel out because they are equal in magnitude, and opposite in direction. Then net electric field is integration of dE cos theta. Then dE means k lambda dx upon x square plus a square and cos theta. Here is very important to understand. This distance is also variable. Means there are two things are variable. One is A is also variable. Sorry, this one is not A. Actually, this one is R square. This one is the R square. One correction here. This one is the R square. Okay, this one is R square. Then this distance is also variable. This distance is also variable. So it is difficult to integrate because first of all, you see here, if thread is at this section, then distance is this. The length of thread is this. And if you consider this distance in uppermost part, then this one is the variable. So this is difficult to integrate. If here is this one is more distance, here is the less distance, here is the less distance, and this distance also variable. This is the O, here is another x, and x is also variable, and A is also variable. Both are variable, and that's why two variable quantities difficult to integrate. Don't worry, we have methods. Suppose from figure, from another mathematical tools I am getting here, because we need more space to derive the law. Suppose that tan theta is equal to, as you know, P by B, perpendicular by base. Tan theta perpendicular by base. Perpendicular is this and base is this. X by R. Okay. Then x equal to R tan theta. Equation 1. And differentiating it with respect to theta. Then dx by d theta is equal to R d tan theta by d theta. This is non-differentiable because this is the x, this is the theta, and that's why it is not differentiable, and that is why it becomes dx by d theta, and d tan theta by d equal to sec square theta. Then it becomes R sec square theta. Means dx equal to R sec square theta d theta. Equation number 2. One is here and second is here. Now electric field is k lambda, dx is r sec square theta d theta cos theta upon x square plus r square. You may use the x equal to, here x is r square tan square theta, this one. It means electric field is equal to integrate k lambda, r is also constant, integration of sec square theta cos theta d theta upon r square into 1 plus tan square theta. And this r is cancelled out, therefore k lambda by r, and this is the sec square theta and cos theta by sec square theta also, and that's why this one cancel. Then E equal to net electric field equal to k lambda by r into integration of cos theta and d theta, and integration, the limit is, this is the infinity, then angle becomes 90, this is increasing, this angle is also theta, and this one is increasing inside, or this theta is also increasing this time, and this becomes minus pi by 2, or this becomes plus pi by 2 after considering many points, minus pi by 2 and plus pi by 2, and this becomes k lambda by r, or sin theta means minus pi by 2 plus pi by 2, and this becomes E equal to 1 upon 4 pi epsilon naught k lambda by r sin 90 degree minus sin 90 degree. It becomes E equal to 1 upon 4 pi epsilon naught k lambda by r into 2. Then E equal to lambda upon 2 pi epsilon naught r. Or direction, if you want to find, then along OX. This is the electric field due to, first of all, I consider a small section. At this section a dq charge is considered, and this dq charge equal to lambda dx, and this lambda due to this charge a small electric field is here, k lambda dx by x square plus r square, because dx and this both are variable quantities, that is why integration is not easy. For integrating this, we consider x tan theta equal to this and putting the value of these all in this equation and getting the answer this. One is here, just you think, if you want to understand again, then I clear it. E is equal to 1 upon, k lambda by r, then upper limit is sin 90 degree and lower level is also sin minus 90 degree, and sin minus 90 is also minus sin 90, then it becomes 2, and that's okay. This is finished. And another case is electric field due to charged ring. Electric field due to charged ring. Here is only ring is added. Ring is just like I am drawing here in oval shape. Oval shape means the ring is looks like this, vertical, this type. Okay, then this is the charged ring, plus charge is here, plus charge, and charge amount of charge is q, and lambda is the linear charge density. And this is the center O, and this is the radius A, and this is the small section dx. At dx, dq charge is placed, and similarly a point P is here where we want to find the electric field, and this is the distance, this one, due to this d. Here is a small charge, here is also a small charge, then repulsion takes place, and due to repulsion this is the electric field due to the small charge, and it becomes again similar way dE cos theta, because theta vertically opposite theta, then it becomes cos theta, and this becomes sin theta. And if you consider another section as like this, then again this one is the again it's electric field in this way, just I am using a scale to draw this one, as like this. This is the dE, this one is the dE sin theta. As you know, both are equal and opposite, and that's why cancel out. And this, due to the horizontal component, this is also 1 dE cos theta. Here is dE cos theta and again dE cos theta. The net electric field is again using dE cos theta. One thing is good here, the variable quantity is less, because this distance is A and this distance is something R, and this is also constant. How? Suppose I am considering this. You can also see this one. This is the ring. Then this distance, either this distance, okay, and this distance, both are same. This distance and this distance both are same. This distance and this distance both are same. This distance is also same. This distance is also same. Then this is not a variable. This is not a variable. This is not a variable. That is very good things in this derivation, and that's why this is very easy. Consider a charge ring. This is the whole charge ring. This is the center where I am holding this one. This is the center, and this is the section, and we want to find the electric field at this. This is the one component in this direction, or other component in this direction, in both directions. Suppose that this is the one direction, and if I hold two strings simultaneously, then this tag, then this tag, then electric field in this direction, just like similarly this one, okay, this one and this one. Finally, integration of dE cos theta. Then first of all we require dE. dE means k lambda dx upon distance a square plus r square whole root and whole square, and that means k lambda dx upon a square plus r square. And another thing, we require the value of cos theta. Cos theta is base by hypotenuse, then r by r square plus a square whole root. And now we will get the net electric field integration of dE cos theta is equal to k lambda upon a square plus r square, all are constant, and this one is the r by ry, and one thing is here dx, then you use dx, and a square plus r square to the power 1 by 2 integration. This one is K is constant, lambda is constant, R is constant, A is constant, R is constant, and this becomes 3 by 2. Here is 1 by 2. Then 1 plus 1 by 2, 1 plus 1 by 2, it becomes 3 by 2. Therefore, the power is 3 by 2. And only one thing is integrate, to be integrated is dx. From where to here? From here to here. Means there are so many small sections we can consider to find the electric field at the point P, and the integration is 0 to 2 pi a. Means this is equal to k lambda r by a square plus r square 3 by 2, and this is the x 0 to 2 pi a. It becomes k lambda r upon a square plus r square 3 by 2 pi a minus 0, and that is why we can write E is equal to 1 upon 4 pi epsilon naught 2 pi a lambda r by a square plus r square to the power 3 by 2. If 2 pi a into lambda is equal to charge upon length, then charge is q, length is 2 pi a, then q is equal to 2 pi a into lambda, and this may be, we can write this formula in simple way, 1 by 4 pi epsilon naught qr by a square plus r square power 3 by 2, this one. Okay, there is no need of this, and just the formula is E equal to 1 upon 4 pi epsilon naught qr by a square plus r square to the power 3 by 2, this. And condition case 1 is if r is greater than a, then a tends to 0. Okay, a tends to 0 means electric field is equal to 1 upon 4 pi epsilon naught qr by rq, and E equal to 1 by 4 pi epsilon naught q by r square. This is behaves as point charge. अगर सोर्स चार्ज कोई भी हो, इस केस में रिंग के केस में, और अगर उसको इंफिनिटी पे बहुत दूर पे निकालना हो इलेक्ट्रिक फील्ड, तो उस सोर्स चार्ज को भी हम पॉइंट चार्ज मानते हैं. अब पॉइंट चार्ज की तरह बिहेव करता है 1 by 4 q by r square. And next case 2 is if r equal to 0, r equal to 0 means at center of ring, then r is 0, then electric field becomes 0. You can understand diagrammatically. Suppose that this is the ring, this is the point, there is plus 1. We consider a small section here and here. Then this one is the PQ, this one is the DQ. A repulsion force is in that direction and repulsion force in upper direction. This one and this one, and both are cancel out. Here is also cancel out. Everywhere cancel out. Then net electric field becomes what? 0. This is the second case. Electric field due to charging at point P. Charged semicircle. Semicircle is just like a ring, half ring. This one is the half ring, and we want to find the electric field at the point O center. For this purpose, we consider this one is the charging. Here is a charge is given, and lambda represents the linear charge density. Linear charge density. It means lambda is equal to charge by length. Charge by length, मतलब q by pi a. Here a is the radius. Okay. Then q is equal to lambda into pi a. And as you saw in two cases, for finding the electric field, first of all, we consider a small section or element, charge element. Suppose this one is the dx, and this dx makes a small angle d theta at this theta. And due to this charge section dq is just like lambda into dx, and due to this section de is here, and this, if this one is theta, then this one is also theta, and this is the de cos theta, d cos theta, and here is de sin theta. Similarly, another section if you want to put here, then again one is de, and it is becomes de cos theta because it is theta. Then here de cos theta, and d cos theta and d cos theta. Here horizontal component is cancelled out. Here horizontal component is cancelled out. Okay, and vertical component responsible for net electric field E dE sin theta. And dE is what is dE? Then k dq, okay, by distance. Which distance? Then distance is this is constant a square, and dq is k means what? 1 upon 4 pi epsilon naught lambda dx upon a square. Here all things are constant, only dx is not constant, but dx is variable. And this one is the dx means what? Angle equal to arc by radius. Then angle is d theta, arc is dx, and radius is a. Then dx equal to a d theta. Why I consider this? Because this is the sin theta, and variable must be in theta. That's why I convert in dx to d theta. Then 1 by 4 pi epsilon naught lambda and a d theta by a square, and 1 a is cancelled out. Then final dE is equal to 1 by 4 pi epsilon naught lambda d theta by a. Then put here the value of d 1 by 4 pi epsilon naught and lambda by a sin theta into d theta. And this is the, now considering the limit. Limit is from here to here, just starting from here. This is the 0 degree, then 0 degree, and here to here means here is 180 degree, then you consider 180 degree. Okay, then electric field becomes 1 upon 4 pi epsilon naught lambda by a, and sin theta is integration cos theta, 0 degree 180 degree, and it becomes 1 by 4 pi epsilon naught lambda by a cos, which cos 180 degree minus cos 0 degree. This one is yes, one thing is the integration of sin theta is minus cos theta, and that's why minus is here. And one thing is minus 1 by 4 pi epsilon naught lambda by a minus 1, it becomes plus 2. Then electric field is electric field becomes E is equal to 1 by 4 pi epsilon naught 2 lambda by a, or E is equal to lambda by 2 pi epsilon naught a. This is also E is inversely proportional to a, radius. That's it. Okay. Due to we discussed here 3 cases. One is charged, other is semicircle, and other is ring. And by using this method, you can derive the formula of electric field due to infinite or finite charged object. Okay, thank you very much.